Imagine waking up to an eerie silence, no phone alarm, no glowing screens, no hum of electricity. Your phone is dead, the lights don't work, and outside the world is frozen in a strange stillness. No traffic lights, no city noise, just a heavy, unsettling quiet. This isn't a simple power outage, it's something far bigger. The internet is gone, your car won't start, water still runs but not for long. A battery radio crackles, all communication is down and the world is cut off. The invisible web of technology that powers our lives has vanished overnight. It feels like we've been thrown back a century in a single night. The cause? Not war, not disaster, but the sun, 93 million miles away. This isn't science fiction, it's a real threat. The sun, a massive nuclear reactor, can unleash violent storms with little warning. Our civilization is built on a fragile foundation of electricity and digital information. Everything, banking, navigation, food supply, relies on a global network of satellites and power grids. This system is both our strength and our greatest vulnerability. We've wrapped our world in a technological cocoon exquisitely sensitive to the sun's tantrums. The question isn't if a solar storm will disrupt our world, but when. Will we be ready? Imagine your daily life, every routine, every comfort suddenly gone. The sun's power, usually life-giving, can turn destructive in an instant. Our dependence on technology is total and our defenses are thin. The next solar storm could change everything. Are we prepared for the day the world goes dark? Or will we be caught off guard by our own star? So what is a solar storm? It's a violent eruption from the sun's surface, driven by tangled magnetic fields in its superheated plasma. When these magnetic lines snap and reconnect, they unleash massive energy. A solar storm is born. These storms follow the sun's 11-year cycle, peaking during solar maximum with more sunspots and eruptions. But even during quiet periods, a massive storm can strike without warning. The energy released is staggering. Billions of hydrogen bombs worth, hurling radiation and plasma into space. This isn't heat, but a barrage of high-energy particles and magnetized clouds racing toward Earth. Satellites like the Solar Dynamics Observatory and Parker Solar Probe watch the sun constantly, giving us early warnings. By studying the sun's behavior, we hope to predict these storms and prepare. Understanding solar storms is one of science's greatest challenges, and our best hope for protection. The sun's next outburst could be just around the corner. Solar storms come in three main forms, each with unique dangers. First, solar flares, intense bursts of X-rays and ultraviolet light, hit Earth in just over 8 minutes, disrupting radio and communications instantly. These flares can cause hours-long blackouts for pilots, ships, and emergency services. Next, coronal mass ejections, or CMEs, are massive clouds of plasma and magnetic field hurled into space. CMEs take 1 to 4 days to reach Earth, giving us a brief window to prepare. Finally, solar proton events, streams of high-energy particles, can penetrate spacecraft, threatening astronauts and damaging satellites. Earth's magnetic field and atmosphere shield most of us, but satellites and astronauts are at risk. Each type of storm can cripple technology in different ways. Together, they form a triple threat from our own star. The sun's fury is unpredictable and always dangerous. Our only defense is vigilance and preparation. The next storm could strike at any time. A solar storm's journey begins with a colossal explosion on the sun. A CME blasts a magnetized cloud into space, its orientation determining the damage it can cause. As it travels, it creates shock waves, accelerating particles that reach Earth ahead of the main cloud. These advanced scouts bombard satellites and warn of the chaos to come. The main CME takes 1 to 4 days to arrive, tracked by satellites like Discover. When it nears Earth, we get a final warning, sometimes just an hour before impact. The real battle begins as the CME collides with Earth's magnetosphere. The outcome depends on how the sun's and Earth's magnetic fields interact. The cosmic tsunami is about to make landfall. Are we ready? Earth's magnetosphere is our invisible shield, generated by molten iron in the core. It deflects most solar particles, protecting life and technology. When a CME hits, it compresses the shield, storing immense energy. If the CME's magnetic field opposes Earth's, magnetic reconnection opens a channel for energy to pour in. This triggers spectacular auroras. Beautiful, but a sign of a massive geomagnetic storm. The more intense the auroras, the more powerful the storm. When the shield is breached, our technology is in the line of fire. The auroras are a warning. The sun's energy is breaking through. When a geomagnetic storm overwhelms our magnetosphere, chaos follows. Satellites are the first victims. Damaged electronics, lost communication, failed GPS. Power grids suffer as induced currents overload transformers, causing blackouts that can last weeks or months. navigation and communication systems fail, making precision and safety impossible. Astronauts and even airline passengers on polar routes face dangerous radiation. The systems we rely on every day, electricity, water, food, transport, can collapse in hours. The sun's fury can reach us on the ground and in the skies. Our modern world is more vulnerable than ever. Are we ready for the chaos a solar storm can unleash? In 1859, Richard Carrington witnessed the first recorded solar flare, the start of the Carrington Event. Hours later, a massive CME struck Earth, creating auroras so bright they were seen in Cuba and Hawaii. Telegraph systems sparked shocked operators and even worked without batteries until they failed completely. In 1859, society survived, technology was simple, and life went on. The Carrington Event was a warning shot, a demonstration of the sun's power. Today, our world is far more dependent on electricity and technology. If a storm like Carrington's hit now, the consequences would be catastrophic. The sun showed us its strength once before. We ignored the warning. Will we be so lucky next time? What if a Carrington-level storm struck today? The result would be a global catastrophe. Power grids would fail as transformers burn out, replacements could take years. Blackouts would last months, maybe longer. No lights, no water, no communication. The internet would collapse. GPS and satellites would be crippled. Supply chains would break, no food, medicine or fuel for cities. We'd be thrown into a pre-industrial world unprepared to survive. The economic cost could reach trillions, the human cost, incalculable. The sun has done it before, and will do it again. It's a low-probability, high-impact event. Are we living on borrowed time? Our digital world could vanish in a flash. The next solar storm could be civilization's greatest test. Are we prepared? The answer, not really. Awareness is growing, and agencies like NASA and NOAA monitor the sun around the clock. Power companies are starting to harden grids and develop emergency procedures, but retrofitting infrastructure is slow and expensive. Our best defense is knowledge. Researching the sun, improving forecasts, and preparing for the worst. Missions like the Parker Solar Probe are unlocking the sun's secrets. We can't stop solar storms, but we can predict and prepare for them. The sun gives us life, and threatens our way of life. Respecting its power is essential for our future. The next storm is coming. Will we be ready?